Okay, so in this video, I will show you how to draw this diagram in Cubit, and then how to apply the boundary condition, including displacement and force, and then how to mesh this, and then how to export this into files where you can read that in MATLAB. So if you open Cubit, this is how it look like. So the way we will create this geometry is we will create this point by point. So we will enter the coordinates of all these corners, then we will draw lines, and then we will create the plane, then we will mesh it, we will apply the boundary condition, and then we will export these into some files. So the first thing is, if you go to this command panel here, so the first command here is the geometry. You click on the geometry, and then you go to the this option here, which is vertex. So we are now creating a vertex here. So as you see here, you can create it. If you click here, then you click on the new here, and then you can see that you can do it by different ways. So we will do by using coordinate option. So if you click on the coordinate, then you just need to enter the x, y, and z coordinate of that point. So in this case, we can start from 0, 0, 0. So if you click here, it will create this one vertex. And in addition to this, it will create this command here, that create vertex 0, 0, 0. And the way we will use this command is that we will create a new journal file, which is you can click on here. So if you click here, it will open this new journal file, but then we will write here reset. So reset means that it will reset the qubit here. So if you click on this and run it, so it will just reset everything. Now the better way is to change this to this Python version. So if you click on the Python version with the reset there, so it will create this qubit cmd, and then within commas it will be the command that you want to execute here. So we will be using this journal because journal is the most efficient way to create your geometries, and then change it if you need to. Okay, so as you can see that we have this one command here, but first we need to create this qubit cmd. So it's better to create a few of these commands because we will be using these again and again. So the first command was vertex 0, 0, 0. So if you again click it, so first it will reset, and the second command is then 0, 0, 0. So it will create a vertex at 0, 0, 0. Now we can create the other vertices by just changing the coordinates here, or just changing the this journal file. So it's easy to do it with a journal file. So if you just create the next command here, so the next one is that we want to create this this vertex here. So we know that the distance from here to here is 50. So it will be just you changing the x and y and z are the same. And then if you just copy and paste, so then the second point is this point here. So for this point, then you just change the y and x is the same, so 50, 50. Then for the next point, which is this point here, again y is the same, but you just change x to 100. And then for the next point, which is this point here, so which is 100 and 100. So then you enter all the coordinates, so 100, 100, and then it was 150, 100. And then 150, 150. And then this is another coordinate. So here then you change the x to 50 and y is 150. And then the next point, which is this point here, so again x is 50 and y is 100. And then another point is this point here, so where x is 0 and y is 100. So we created all the points. If you run it, you will see all the points here in Cubit. Now the second thing is that we need to create now a curve starting from this point to go here, there. So for it, we can, if you don't know the command directly, so the easy way is to go again to the geometry, and then now we will go to the lines or curves. So if you click on the curve, now you can see that you can create, if you click here, then you can create a new line. So you can see that there are different ways to create the line. We will choose the polyline, which can create a line for different points. So we will click the polyline here, and now you just need to enter the numbers of all the vertex. Now you can go and see here in this view here in the model tree all the vertices. So in our case, we have these 10 vertices. So either you enter the number here manually, or you just click here, and then you press with the control or shift, and then you can see that you can, if you click on the point, it's automatically appearing here. So you just pick all these points, and then you just say apply. So you can see it created this line here, and the command here is that you can copy from here, is that create curve polyline vertex from 1 to 10. So I will again put it here, and now we also need to close this diagram here. So I will need to close it here. So then this means that I will need to create another polyline between vertex 10 and 1. So I will just remove the remaining, and now if I run it, so it is a closed polygon. Now we need to create a surface from this from these curves. So now again I will click on the geometry, and then I will go to the surface here, which is this surface, and again I will click on the new, and then there are different options. So you can create circle, triangle, ellipse, different things, but in our case we want to do bounding curve. So if you click on this, and now here you need to enter all the lines individually, so their ID. If you don't know their IDs, it's again available in the model tree. So if you click here, you can see that we have all these curves. So again, if you click on this line and then press on the command or control, so then you can select one by one, and it will appear in here. So you select all these curves and then apply. So if you do that, it will create this this surface here, which is what we want here. Okay, so now after creating the surface, the next thing is to create the mesh. So to create the mesh, you go to the geometry. So the first one here is geometry, the second one is mesh. So if you click on the mesh, now you can create a mesh on the curve, on a surface, on a point, on a in a solid. We will create a mesh on a surface here because this is the surface. So the first thing is that you click on it. Now we need to define which type of element that you want to create. For example, in 2D you can create a quad element or a triangular element or some more. So if you click on this mesh scheme, so there are different schemes that you can create. So for example, tri mesh and pave mesh. So pave is normally used for the quad. So if you click pave and then select the surface, so where we want to apply the scheme, and then apply scheme. So now if you create a mesh for this surface, it will be a quad mesh. So again, you need to copy this command and put it in your into your journal editor. Okay, so now another thing for the mesh is that we need to select the size of the mesh. So if you then again click on this option here, now there are different ways to create the density of the mesh. So one is the automatic way, so where you can just using this slider, you can create a fine or coarse mesh. Another good way is to create by using a size. So in this case, for example, if you want to create an element of size approximately maybe 4 or 5, so if you do that, then you will, okay, so this is the surface, and then the approximate size is here. So it will be 5 in this case, and you can say apply size. So here you again have this another command is that surface 1 size 5. So this one is the surface that you want to mesh, and you apply we already applied size, so you just now click on the mesh. So if you click the mesh, so again the command will be here so mesh surface 1, and again you copy the command and put it here. So now at this stage we have created the geometry, we created the mesh. We now, for example, if you're not happy with this mesh, you want to refine it. So in this case, the previously we just choose a size of 5. You can change this to, for example, 2, and you just run this thing, and it will automatically change everything for you. Okay, so after doing that, now if we want to go back to the 5, so it is that simple. Okay, now another thing is that we want to now create boundary conditions. So one is here that we want to apply the displacement boundary condition, and here we want to apply the load. Okay, so the load we want to apply it's some not at one node, but we want to apply this at some length. So we cannot select a length here, so we will first need to split this this line here. So even so what we will do, we will just run the the journal editor, the commands up to this surface before creating the mesh. So if you say play it, and now we can split this this line here. So if you again go to the geometry, click on the line, and again you now need to modify the lines. You need to click here, and now you need to, there are different ways that you can do different things. So we want to split this line. Now we want to curve this, so we need to put the ID of this curve. So if you click on here, it will automatically pick the number. And now we want, you can do a fraction, by vertex, by different things. So we just want to do by distance. So maybe we want to do it by, for example, a 10 distance, and then from which vertex we want to do it, from this vertex. So if you do this from this vertex, and then you just say apply. So again you can see the split curve 7, distance 10 from vertex 7. So we already did that. So it will be, so this command then should be before this mesh command. Okay, and now you can see that we have this another curve here. So if you run it, so now again you can see that you can apply force here, and you can apply displacement here. So now now we are ready to apply our displacement. So but there is to apply the boundary condition, you go to this option here, so FEA boundary conditions. So if you click here, in our case we don't want to, we are not actually applying the boundary condition, we just want to select the nodes that we will be using in our MATLAB code. So both for the force and displacement we can use this option here, which is the displacement option. So if you click here, now there are different ways to do this. So you can apply on a curve, on a surface, on a volume. So we will do this on a surface here, so curves, and then you need to enter the number. So if you click here, it will pick its ID automatically, and it's all, so it's okay. So if you just apply, it will create displacement on curve 1 dop all fixed. So this is what we want here. And then another thing is that we want also this surface here. So if you click here, it will automatically show here the entity number. So this curve is 11. So the another option is that you just write it here. So it will create these list of these two lines. So if you run it again, you can see it that we have created this boundary condition. So one is this boundary condition which is applied here, and one is boundary condition which is applied here. So we can pick these nodes in the in our MATLAB. Okay, so now everything is done here in Cubit. Now we need to export this file to something that MATLAB can read. So for this you will go to the file, and then you need to export. So you will need to export this is Abacus. So there are different options that you can export to. So if you choose Abacus option here, and then just give it some name. So I'm giving it the step name, and the file is what we call is INP file. So this is the Abacus input file. Okay, so if you save this, and because we already have a file, so we will replace it. Okay, so now there are this option. So you have the two options. So one is if you click on the advanced here, so then you will have these additional options. So here you click on the 2D because it's a 2D problem, so it will not create a Z coordinate for the nodes. And now here you have the option to write node file. So you will click this option, and then you will give here where you want to save the file. So you will give it a name, the element file. So if you just click on the just give it a name, for example elements.date, and then save. So we will replace it, and then okay, so the first one is for the nodes, not for the elements, so we will need to do it for the nodes, and the second one is then for the elements. So if we just give it a name elements.date, which is a data file, and that's it. So if we just finish it, so it will create this long command, so which again you can put into this Cubit CMD. Okay, so at this time we are, so if you for example want to change the to 10 for example, and you run it, so it will create a very coarse mesh, and now this is automatically saved into your files. Now we can go to the MATLAB and we can import these data files. The data files that I save is these files. So as you can see, one file is saved for the nodes, one is saved for the elements, and one is this journal file that it's better to save this journal file because you will be using it all the time. So you can give it a stepshape.journal file. Okay, so just save it again, journal file. Yep, so save and then replace. Yes, okay, and and then we have this step.inp file, which is the Abacus file. So if you open all these file in some editor, for example in Atom, so this is how it looked like. So the nodes is just a coordinates of all the nodes. So in this case, for example, we have 156 nodes. The elements are that for each element, this is the element number, and then these are the nodes number for each element because we are using a quad element. And this another thing is that this INP file, which is the Abacus input file. So if you open this Abacus input file, it will have these two node sets. So what one is that we apply in our case for the displacement boundary condition, and one was for the load boundary condition. But if you create more sets, so these are coming from here. So the first one is this one, and the second one is this one. So in this case, you can see there are only two nodes, and in this case there are about 6 nodes, 1 2 3 4 5 6, and this is the same. So the 6 nodes are here and the 2 nodes are here. Now obviously we cannot import this complicated file into our MATLAB. So just if you copy this this thing, and the way I'm doing it is that I created this MATLAB simple file, and I will just say the two variables here. So BC data is the name of the file, and this is BCXY. So boundary condition where I want to import impose the XY. So which is these nodes. I will just copy from there, and from here I have just 2 nodes. So I will just paste here. If there are multiple nodes, so then you can, for example, create multiple lines like this. Okay, so this means that everything is now done here. Now we should go to our MATLAB here. So for example, here I want to import these files. So first I will, for example, either I will put all these files in this directory, or I will add path and then give the address to that folder where I have these elements and nodes files. And then I will just say load element.dat, and then I can take connectivity. So because I just want from 2 to 5, which is so for the elements, because the first one is just the element number, the actual connectivity start from here. So from 2 to 5, from 2 column to 5 column. And similarly for the nodes, we just need the x and y coordinate, so which is the, so if you click on the node, so you just need the x and y coordinates, so the second column and the third column here. So if you do this, and then you can you will have all the your data. And then if you open this MATLAB file bc.dat, so automatically you will pick these nodes here, so bcxy, and then the traction node, that the nodes traction, which is this one, and the bc is this one. Then we are now can plot this thing. So if you look, this is again, everything is now in the MATLAB. So, and again we can see that, you know, this boundary conditions are picked here automatically and picked here automatically. Now for example, if I go back and I want to change the mesh, so for example I want a dense mesh here. So if I change the size to, for example, 1, so it will create a very dense mesh. As you can see, it's very dense. So let's change it to 2. Okay, so again this is quite dense mesh, and this have done everything. So it automatically create the files, so the files will be now different. So now again you just the only thing that you need to now need to do is to just replace the BC data file, because now it's changed. And this you can take from your this INP file. So as you can see, now we have more nodes for the first option here, and also we have more nodes for the traction one. Okay, so obviously these are multiple lines, so I will just put this 3 dots at the end, so it will be, and you don't need a curve here, so that's it. So if again I go here and I run it, so I can see that I can you know, open that mesh, and again you can see that these blue are the nodes for the displacement, and the green are the nodes for the traction.